Okay, so good afternoon, everyone. Just to be aware, you're on mute. If you have any questions, please put them in the chat. We have a multiple number of speakers today, so I'm sure they'll be keeping an eye on that so they can answer them when they come up. If not, we will go through questions at the end. If you do put in questions, make sure they're to everyone, just so that people don't suddenly see an answer and have no idea what the question was. Today's session, this session is session 3AU. Please make sure you give feedback at the end of the session. Yes, feedback. I just did feedback. Questions, dumb questions. I can't think of anything else. Hope you're all sitting comfortably, and we will begin. Over to you, Chris.
Okay, good afternoon, everyone. My name's Chris Walker. I'm an offering manager with IBM. Hopefully I've met most of you before in the past. If not, it's good to meet you virtually for the first time. I'm joined today by two of our colleagues at development partners at 21st Century Software. We've got Dan Rule and we've got Butch Rambush. And the three of us today are going to be talking around the subject of performance management, capacity planning, and some of the more details in that. So we'll get straight into this. Firstly, I'm sure many of you have attended sessions this week and last week. You know, the conference is free, and in lieu of conference fees, or the GSE are looking for you to contribute to their charity this year, which is NHS charities. So I've done a lot of good work supporting the NHS across the UK this year, and obviously going forward as well. So if you have time, please do contribute. Okay, so what are we going to talk about today? We're focusing really on some of the fundamentals around IBM's positioning around AI ops, and particularly the topic of performance management, capacity planning, and why it's still vital, and probably even more important today than it's been in recent years. When we look at hybrid cloud environments, we have workloads that are less predictable. They cross operational domains. It makes it harder to manage, especially when you've got these older tool sets that may be disconnected. They don't provide you the insights to analyze performance and plan for the future capacity needs of these workloads. It's often exacerbated by a lack of skills within your team and maybe an increasing dependency on a smaller set of experts. We're going to talk a bit about IBM Z performance and capacity analytics, the way it can help address some of these challenges. We're going to look at how we can access, curate, make performance and operational decisions in a timely fashion, forecast future utilization. And we're going to run through some scenarios based on some real life examples that we hear from customers. We'll guide you through some of the newer updates, and particularly focusing on sort of how you might address challenges of understanding planning around what if something happens. We'll also look at the Taylorville Pricing model to ensure you optimize the use of resources and make informed decisions for workloads and planning as well. So let's start with some basics. Performance management, cost control, capacity planning isn't anything new, especially on Z. But perhaps some of the principal needs need to be refocused around the modern world and ensure that we users and stakeholders are really empowered to make the right decisions today. So as we go through into this, let's look at some of the challenges that you have. Hybrid applications, increasingly commonplace these days. I'm sure many of you are in this environment where you have a lot of applications off platform that are using IBM Z as a backend. They're often more complicated than single platform applications. They involve more moving parts, and these parts are managed by more teams, maybe siloed, and need to be engaged across those domains to address issues. And as the workloads grow fast, the workloads are getting spikier. That causes challenges, particularly for people who are looking at performance analysis and capacity planning. We see, obviously, some of the changes that we've seen this year have made some industries have even more unpredictable workloads, which means that you have to be very much on top of things to address potentially outages or making sure you have the right capacity as you go through there. And of course, all that comes to complexity when you're trying to look at budgets as well, especially when we face economic downturns and changes in the generation of operators and system programmers as we go through there. So as you're trying to address these things, it's important to make sure that you're addressing things for the new users of the platform. So as we move forward, what we're seeing a lot of customers doing is how to manage hybrid cloud environments, including improve that visibility across applications that are spanning multiple clouds, data centers, leveraging multiple technology stacks, and those sorts of challenges. Then addressing that cost of downtime that you have. Applications spanning those hybrid clouds, you need to be resilient across all of them, and that's what we hear when we talk to customers is a top priority of the IT operations team. And then being able to optimize for your costs and also optimize for the skills, so you can make sure that your teams are empowered to do the right work and do it quickly. And certainly for the operations teams, we look at this as a journey to AI ops. And what does this look like in practical terms? Well, as you move through 4 stages of the journey, you'll go from something that's probably very siloed, what we call firefighting, and I hope you're not really at that stage, but ultimately you have the tools and you have the ability to be less fighting problems as they come up and be reactive, but actually be proactive. You understand that potentially you might have a performance problem in the future, you might have a capacity problem in the future. You're making the right decisions around where your investment is and where you're putting your processes and your tools. So this is an ongoing journey as you move away from a manual process to a more automated process. And this is something that you'll hear pretty much across a lot of different domains, but today we're really focusing on capabilities around performance analysis and capacity planning. And for this to really be effective, we divide this into 3 capability areas. Firstly, inspect, so being able to identify potential issues as soon as before they happen. Monitoring will come into this, generating alerts, applying analytics for early detection, and then evaluating this. So you are able to isolate the problem, do that root cause analysis, determine the right action, and then employ capabilities such as machine learning to help you make the right decision quicker, and then act on that. So being able to preempt the disruptions, automating runbooks to help your operations team. And by increasing that level of automation, you can reduce the need for a manual intervention and move forward onto that. So that's a high level view. We're going to focus a little bit more in detail on performance, capacity, and cost on Z. And for that, I'm going to hand over to Dan to go into this in a little bit more detail.
Hey, thanks, Chris. And please, as we said, any questions you have, feel free to stop us so we can answer the question straight away. And I think everybody will benefit from it. Any questions is fabulous. So I really miss being in the room with people and seeing the eyes, and so the questions would be fabulous if we can get some questions in our chat. So let's talk now. What are the key roles within capacity management? There's at least 4 different roles that we're going to talk about within this presentation, but the technical roles are ones that I'm familiar with. I have a long history of being in the capacity management role, from being an engineer to managing capacity across multiple platforms, but across all platforms, it has a similar data input, similar process, and we're going to be talking a little bit about what that is as we go through this. But the technical roles include capacity management. That includes scalability, performance. That includes service levels, and then there's operations roles, which includes things like event management and incident management, problem management. It's not really thought of too much, but within the application development process, there's application development engineers and QA that are part of DevOps, and also when they are putting new function into code, they are running stress tests and load tests, but they need measurements in order to, and that's the kind of role that they're in order to ensure that their product that they're producing will meet capacity and performance standards and service levels. And in IT management, hardware and software costs are tracked within IT management, and those are the folks that will Typically, we'll be talking directly to the technical role folks, for instance, with show back or chargeback, or however you would want to describe it. And they also keep track of Taylorville pricing or whatever pricing model that you have from a software perspective, and also hardware leases and things of that sort. And then finally, within business management, these are the folks that are really, they talk mostly to the IT management folks, but they may talk to the technical role folks. And these are the folks that are external to IT, and they have their fingers on marketing forecasts. They're looking at things that may not be seen in any kind of system consumption data. Those are the folks that you really want to talk to and understand what's coming, and because you may not see it in the history. And then the second piece of this is the business management folks will assist you in categorizing all the technical types of data that you have, like transaction names and job names, and all these need to go into application categories and business categories. So when you're looking at capacity, scalability, performance, you see that from a business service perspective. When you are looking at operations, you see that from the event perspective, because all the events that come in, be it incidents or problems, they're typically going to be aligned with business service names, and you have to translate to the technical data in order to understand why did this event happen and things of that sort. Let's go to the next slide and take a look at what are the key tool inputs for capacity management. So first off, as I think many on this call will understand, system consumption metrics are probably the best in all platforms that I've seen. On the Z platform, SMF is comprehensive, and there's a lot of detail that goes in. And there's certainly some key metrics that you want to focus on, but there's other metrics also that are part of the Z platform. These consumption metrics need to be understood from an architecture perspective, and they must be actually put into a business services framework so you understand why they're important. There's a performance trending database that's part of a key tool input of capacity management. The trending database needs to be summarized in multiple time spans, detailed days, weeks, months, to understand the business cycles so you can align that with performance, which is, again, service levels, capacity, which is scalability, and also cost. So you understand from a detailed perspective, from a weekly perspective, from a monthly perspective, where are you going and what are the trends and what are the consumption patterns that are going on into the future. Statistical analytics, because there's so much data that it's available within the Z platform, are key. That includes not just being able to run statistics like standard deviation, linear trending, nonlinear trending, all the different statistical methods that are possible, but also the statistical visualizations that are part of understanding your data, because there's so much data that's part of the platform, and being able to conceptualize that data is really important. Diverse reporting and audiences and tools. So what that means, diverse reporting audiences and tools, that means that it's not just the performance trending database that potentially all the technical role folks are looking at, but there's other audiences that are part of that looking at IT that didn't look at when I started in the business. So these include like Splunk and ELK and other types of external trending and visualization tools that are part of the typical enterprise. Let's take a look at the next slide. What are the key data inputs? So when I started in the business, much of the focus was on history. So resource consumption measures, we looked at history, we had a performance database. All our real-time monitoring was part of a different product. But as we go into the future, for instance, an IZPCA current product can now look at current data up to almost a minute of current time. So history, current, they all kind of merge into a full picture of what's available within the Z platform on the resource consumption measurement perspective. It doesn't replace any of the real-time tools like Omegamon and things of that sort, typically, but it augments that and gives you a look back into history and a full, rich historical view of what has gone on in the past. And finally, other data inputs is future, because in the past we've mostly trended by steering in our way, but the future non-historical data that's available, business forecasts, acquisitions, and other events that impact the forecast is important. All this goes into a measurements that are performance, capacity, costs in terms of the things that you look at, and they're trade-offs between each other. You look, folks and companies do not have an infinite amount of money to be able to put as much capacity in the floor as they want. And service levels are kind of the goal. The business service levels are key to understanding how much scalability and how much cost you can spend. All these measurements, current and future SLAs, are put in context by history and whatever future forecasts are available. Let's go to the next slide. So the historical data drives service level forecasts and variance. All these, I put these in these different categories. Maybe you have additional categories, but I kind of think of it as there's typically application, infrastructure, and business forecasts and variance. Application, in my past, new functions within the application development lifecycle. That was the typical forecast that had the most variance, and what I paid attention most to was the forecast of new functions coming into the production environment. Mean time to failure defects are also important, and architectural limitation. Understanding your architectural limitation. Basically, that means how much can you push through a particular disk device or CPU or infrastructure or systems. Within the infrastructure categories, variances happen within scheduling. If you have jobs that use the same data, that would impact your variance in terms of your forecast. And software upgrades from an operating system software, a new Z release, it potentially impact your forecast of future consumption on your hardware. And finally, business. We've talked a little bit about this from a market promotion, news event, new government laws. All of these contribute to understanding where you're driving your IT car to understanding your capacity, performance, and cost. Go to the next slide, please. So, with all that said, capacity management has monitoring real-time and trending data. The data just being static, it needs to be analyzed. It also needs to be reported. That includes visualization, and then forecasts come out. And then communicating the results to the proper audiences is fundamental to getting better at your analysis. If you don't communicate, your analysis will over time not be as rich or understandable either. And so there's capacity, performance, and costs, as I've said many times. And then there's other stakeholders that are have key inputs to your understanding your analysis, as well as them understanding what their goals are from their process perspective. So incident, problem, change, and event. The incident and problem, which I've been involved with in the past, understanding root cause of a particular event, all the data that's within the training database is fundamental understanding what's going on. Let's go to the next slide. What are the common methods for measuring capacity and performance? So in order to manage the cost curve, understand who your top consumers are and tuning that top 20% where you have a huge return and you can delay any kind of capacity uplift. Also tuning your application to increase your reliability and ensuring that any kind of QA statistics that come out of your performance database, that's a really important thing. So you could push down the number of times you rerun your applications, your transactions, or your batch jobs. That's real important in order to decrease your costs. Measuring new technology when you uplift for instance, if you uplift your PEX from a Z14 to a Z15 and added more memory and added more zips, understanding what what are the impacts for capacity, performance, and cost within the taking advantage of new technology? Because the business, the IT business folks really want to understand what their investment, what is the return value of upgrading their technology. That's important to really conceptualize that for that audience. And then strategic planning aligning with the business. This slide, we see, we're going to, I think there's some additional slides in this deck around Taylorville Pricing and that pricing model, but having measuring capacity from a cost perspective is important. In this case, this is measuring Taylorville Pricing in ensuring that you fit within the Taylorville Pricing contract that you had for that year. Let's go for the next slide, please. And then what are the key outputs for the capacity management process? So self-service reporting. I put that in bigger letters because there's usually within the capacity management group, there's usually more other people than the capacity management group. So enabling self-service reporting, these are all common reports within IZPCA, except for the bottom right, which is a Splunk example. But the management reporting, technical reporting, all these must be readily available for others, which are some of the roles that we talked about. You know, the development folks, the IT management folks, all those folks need in their role, they're reporting geared to the audience that you're serving. And then enterprise reporting, fitting the IT data into other reporting is fundamental in today's environment. I think the next slide, yes. Next slide is Butch. So Butch is going to talk a little bit more about IZPCA and talk through this. And then I'll be back in about 10 slides or something.
Thanks, Dan. Before we get into talking about IZPCA, I want to talk a little bit about some of the challenges and the disciplines and recommendations Dan was making with regard to capacity planning and an approach really isn't new. It's been around for a number of decades, and a lot of customers or organizations have been utilizing those kind of disciplines. And in order to do that, it takes processing a lot of data. So this is kind of a picture of a typical approach that's been going on for 20, 30, 40 years now for some organizations. At midnight, you take all of your SMF data and you spin it off to a daily file, and then you begin to process that data so that at some point during the day, maybe early in the morning, it could be mid-morning, you'll have data available for people to report on. The volumes of these data has led to problems with getting it processed in a timely manner. Organizations have implemented additional processes to try to take that big SMF file and split it up into multiple files so they can get some concurrency. And it's helped to alleviate to a degree, but still by and large, it's a cumbersome batch-oriented process. If you have errors, you've got long rerun times. The process of curating the data and storing it in the database has largely been something that requires special skills in your organization. It is somewhat of a homegrown process. Even if you're using a vendor-provided solution, the customization of that vendor-provided solution does require a significant amount of expertise. Those databases and the approach have stored a huge amount of data and taken up a lot of storage. And then, by and large, it's 24 hours or more until people can get the data and report on it. What we're going to talk about is really the need or the way that with IZPCA, we've approached this in kind of three areas of modernization. We've modernized the collection of data, and I'm going to talk a little bit about that. We're going to talk a little bit about the modernization of how we curate and store the data. And then, of course, the modernization of how we deliver the data and allow you to get that information to the people that need it for their jobs. One of the things that's true today, it's been true for years, and is that the analytical insights are vital to keeping your system healthy and running. It's probably even more so now as the ZOS systems have been integrated in the cloud and delivering the cloud technologies for your organization. And so this is what we're going to talk about with IBM Z Performance Capacity and Analytics, which is a mouthful, so I will probably refer to it as IZPCA going forward. IZPCA has three primary areas that we deliver. Performance analysis, that's looking at kind of what the system's doing now, how are we delivering our service levels, are we meeting our objectives and our agreements. For many organizations, service level agreements, if you don't meet them, there can be financial fines to agencies, government agencies, or to cooperatives within the business area. Capacity forecasting really is looking forward, taking our historical data, doing some trending analysis, and looking at when will we not be able to meet those service level agreements going forward. And then cost management, really kind of two areas here. One is the traditional resource accounting, and that is being able to identify the cost of various IT resources and be able to relate those to the business applications. You know, if you're manufacturing cars, you wouldn't take the cost of steel and just kind of just leave it out there as overhead. You would allocate it out to the various models that you're making, so that if you understand the cost of a model and what you're making, you know, you can kind of make some intelligent decisions. IT is the same way. We want to be able to take those IT costs, which are significant, and be able to allocate them to the various applications. And then also in the area of cost management is the ability to manage your contracts with IBM and other software vendors, understanding, you know, how those costs are, whether it's tailor-fit pricing or a rolling 4-hour average, being able to understand where you are in relation to those. The next slide, please. So in IZPCA, we can process any structured log. And what I mean by that is any file that you can define the record layouts and the records. We can process that data and provide the ability to curate the data, store it in the database, and report on it. We've talked primarily about SMF RMF because it's the elephant in the room. It's the biggest input file we have across organizations. But we can also bring in information from your distributed systems, application data. If you have application data that you need to report on for volumes and performance and those kind of things, we can do that as well. Next slide. Now, in terms of talking about modernization, I said I was going to talk about modernization of the collection process. One of the things that we've done with IZPCA is we've made the collection a continuous process. It runs throughout the day, and it's what we would call near real-time collection. And what we do is we utilize the SMF exits, and we pull off the SMF records that we need, and we put them on a log stream, and we transmit that log stream to our collection engine. And the collection engine will then, in near real time, will summarize the data, curate it, pull off the elements, and store them in DB2. Because we do this continuously throughout the day, and we utilize the zip engines, we've significantly reduced the overhead for the collection process. We have some customers, we have at least one customer that's running over 90 LPARs, and they're committing that data to DB2 every minute. So within 1 minute of a SMF record being written by one of their systems, they can then report on it. We also have a forecast engine that allows you to, on a regular basis, to generate forecasts utilizing that DB2 data, and then it stores it back in DB2 so that you can report on it. The curation process, I'm going to talk a little more about later, how we've modernized that, but we've taken steps to significantly reduce the amount of data that's stored in the data tables. And then, of course, this data is available for reporting by the various people in your organization. We still deliver over 1,400 3270 reports for people that like to utilize the traditional 3270 type reports. But in terms of modernization, we're leveraging Cognos for our reports, and I'm going to show you some examples of that. But to what Dan was suggesting or recommending in terms of self-service, the Cognos reporting tool really provides you the ability to give your people in your organization the ability to request their own reports, request reports on demand, be able to drill down to lower levels of information. And this helps to alleviate the demand on the personnel and the expertise necessary to write reports. And then we also provide the ability to spin that data off into dashboards for the organization. The next slide. So I'm going to take you through a few scenarios, examples of how this might be, and talk a little bit about more about some of the modernization. The first one is in the area of key performance metrics. Now, what is a key performance metrics in the context of IZPCA? Traditionally, if you look at the way that most, and if you're running any of these processes with SAS or whatever, the traditional method was to read an SMF record, interrogate all of the data on that SMF record, and write all that data out to a file or a database. And hence the long runtimes and the a large amount of data that's being stored. And what we did is, in terms of trying to get this into a more manageable environment, is we went to subject matter experts within the various disciplines in IBM. So we talked to ZOS experts, people that would be looking at customers' data and helping them solve performance problems. And we asked those subject matter experts, what are the elements you have to do your job? And what are the reports that you have to do your job? And we took that information and we eliminated all of the other chatter and just stored that smaller subset of metrics. And we've seen upwards of 90% improvement in collection time, as well as a 90% reduction in the amount of storage consumed by the DB2 databases in storing the data. So this particular example we're looking at is around ZOS, the ZOS key performance metrics. And this is a dashboard, one of the standard reports that's provided. And you can see in this dashboard, we've got KEC CPU busy. We also have the LPAR CPU busy on the within the KEC, processor storage and others. We'll go to the next slide. Within the key performance metric and component, as well as other Cognos reports, you have the ability to look at lower levels of data. In this particular case, we're looking at the KEC CPU busy by hour, and we'll see each line represents a day. And so it's kind of a nice report because it allows you to see the regular pattern of usage within your environment. But if you see an anomaly, you see one line there that's jumping out. If you wanted to, you could go to that day and look and see what happened. Why did utilization drop so low? And then of course the spike, picking back up. Go to the next report. This report's an example of looking at the LPAR CPU busy by hour. So here we take what was being utilized at the KEC, and we look at within each LPAR, we can see how much each LPAR is using within the KEC. Go to the next report. Now, within the databases, we have different levels of granularity. We've got what we call timestamp data or interval data. We also summarize to hours, days, weeks, and months. So here we've gone from the hourly view. Now we're looking at an interval view. So now we can actually see for all of our RMF data, we can see each interval what is going on within the system. Go to the next slide. We can also look at our workloads. So we can take that same information at the LPAR level. Now we can drill down and see which workloads contribute to that work. The workloads typically would be like your workload manager type definitions. And if we go to the next report, here we can see even at a lower level, we can look at our service classes busy by hour. So we've taken that same information. We started at the KEC and we were able to drill down looking at that same time interval to the point now we can see the within each service class, which ones are contributing to the usage. Next slide. This is an important area, especially if you're utilizing a pricing tool like 4-hour rolling average, is understanding your capture ratio. The capture ratio is really a measure of how much overhead versus how much actual application usage you have in your system. So this helps you to identify, especially at times when you're getting to those peak usage, where you may need to do some tuning, because otherwise your 4-hour rolling average is you're paying a lot of that for overhead as opposed to just strictly application use. So this is a good report for a lot of customers to keep an eye on. Next slide. So let's the second scenario I want to talk about is exception management. And one of the things that's true today, it was true 40 years ago, and it's even more true today, is the volume of data and the number of things that you have to keep after. Organizations now have so many CICS regions. It's hard to look at each region and check in and say, well, is it running okay? Same is true for the rest of the system. Just a large amount of data to manage, and so managing by exception becomes very important. And we have an exception management capability out of the box. We deliver with some traditional exceptions around your workload manager, channel busy, performance index, storage, and CPU. But you can also add your own exceptions to manage. And so the exception management capability allows you to have the system notify you when something is out of norm. Go to the next slide. Within the component, you can drill down to specific kind of exceptions. There's various reports. So here we drill down to look at exception detail for this particular exception. And if we go to the next slide, you'll see that we can drill down to even a very specific exception and get all of the details. One other thing with regard to the exception, remember, we've modernized the data collection. And with the data collection now being near real time, another capability with the exception management is you can actually have the system write a WTO out to your system. And with the WTO, you now have the capability of instantiating some automation rules if you want to. So, if you wrote a WTO out when your CPU utilization was exceeding 90%, you might have an automation rule that varies some capacity online to help you to better deliver service level agreements. With that, I'm going to turn it back over to Dan and let Dan take you through some capacity planning scenarios, and enjoyed very much talking with you and hope to meet more of you later in person.
All right, I think we're going to scenario 4. Do I have this correctly?
So your number 3. Number 3.
ZOS. So this is tracking MIPS usage and looking back in time. So we can see some peaks on 3.19. We see some peaks on 3.1. And let's go to the next slide. And then drilling down within this, various workloads by system. This is a drill down by system and LSPRs. And you can see that some of these systems grew larger on certain days, like specifically March 1st and March 19th. It looks like it was M1 that grew bigger. Let's go to the next slide. As we drill down further, we exceeded the capacity on the LSPR capacity that's rated for this machine on those dates. So as you drill down, you can see specifically what dates as you're trending up and what days your peak. Capacity planning is always trending by peak. Let's go to the next slide. And what were the workloads that contribute to exceeding that peak? And within this view, this is a drill down by service class, understanding what was the peak that was causing the workload increase. And that was happening on March 1st and also March 19th. Let's go to the next slide. This is workload usage by day, and pretty much the same thing we saw in the first slide we saw in scenario 3 as we started this scenario. Let's go to the next slide. And this is specifically looking at fixed workloads, and it's within these workloads we see the increase that was occurring. So all this, as you look through this, previously in many in the past, being able to drill down was not really an option. Many of the reporting that we did in the past decades ago did not have drill down. It was a static HTML or it was a static report that we produced, and then we had to physically go through, and was it interactive as you were walking through each of the various from going from the tech side down to the actually the workload side. Let's go to the next slide. This is looking at a different view of all the different service classes, and looking specifically at March 19th, and you can see that some of these workloads increased, mostly the purple there and the green a little bit. Next slide. This is mixed service class by peak day, looking at all the different service classes and identifying which, looking specifically at trending by each of the service classes, so you can easily see which of these service classes increased. Next slide. Finally, we're going to look at capacity planning for kicks. Within this tracked transaction volume, you see that 3 of the days out of the 5 here, they started to increase on March 19th and March 20th. So March 19th and March 20th, we had an increase in this case, CSS regions. Go to the next slide. As we drill through this, on the far left there, the top graph there, volume and CPU seconds, you can't see that, but if you float it over there within the Cognos tool, you'll see that this transaction name is CTSG, and it's readily apparent that that transaction contributed to the increased CPU and volume, CPU seconds specifically. Let's go to the next slide. So with this is the detail that also that Butch talked about. CTSG, you can see the nature of this transaction. It increased significantly within, I think, response times. I think there's another slide coming, but you also can see that this is a transaction that's connected to DB2 response, to DB2. So you can see that the DB2 request 1,073,931. So this is a KICS transaction that talks to DB2, and you can also see that the level of detail file control requests on the far right there. The file control request, this transaction significantly had a number of IO going to files to complete the transaction. Let's go to one more slide here, and then as we look at the average response time for the CTSG transaction, you can see that on March 20th, it had a 0.144, which is significantly out of bounds to what the normal was. So something happened on March 20th. The previous slide we saw all the detail for that transaction and further detail if you look going back even further in history to see if this was a recurring event. But this is an example from that's possible with doing drill down from a KICS perspective. I think now Chris is going to talk a little bit about Taylorville pricing.
Thanks, Dan. Yeah, so I'm going to finish up with a scenario around tailor-fit pricing. I know that's a hot topic for a lot of people at the moment. Particularly, I want to look at this from a more technical side, as in what's the impact to you. I have a full session of this coming Thursday in the same time slot where I'll go into more detail, but I'll start with just to kind of see how it ties into this and give you a sort of high-level view. But the key thing to remember when you move from what you've been probably doing for a number of years with a rolling 4-hour average and your MLC costs, you're really focusing on a small period of time to keep that one period very, very optimized and tuned. But when you move to tailored fit, everything is all MSUs are MSUs and they cost the same regardless of whatever time of the week or day that they occur. So there's a lot of other sort of changes that you have to think about when you move to tailored fit. You have to start maybe with a planning and understand what workloads you have out there, what's running on each LPAR, which falls under maybe a dev test container, what's running in production, is anything being shared across those environments. And then critically, you need to be able to manage that because you want to make sure that you're making the best use of your MSU consumption baseline, where you're trending towards the end of the year, how's your container doing, so you can also forecast that future consumption. In the past, you'll have used things such as capping to keep things under control, but capping really doesn't make that much sense under a consumption-based model because the work is the work, and if you cap and constrain the workloads, you're really just delaying the completion time of that work, and not taking probably full advantage of the capabilities of the machine that you're running on. So it's important to understand, where's your workload running, how's it doing, and keeping a good tab on how that's performing. Once you understand that, you can then start to think about what's the best way of optimizing it. And that, as I say, under a 4-hour rolling average, you're focused on when your peak is running, but you really want to maximize the deployments across the whole 24/7 period that you're looking at. So when we're thinking about, this is a key role for a performance and a capacity person to start thinking about. You want to have a view of who are your top consumers, which applications are running there. Are there particular applications that are consuming more MSUs than you were expecting? Maybe that workload that ran every Saturday and didn't really affect the rolling 4-hour average is actually a little bit inefficient. You haven't recompiled it for a number of years. But now it's consuming, maybe more MSUs than is required. So you might be able to look at taking advantage of later compiler and hardware technologies to free up some MSUs there and make better use of that workload. Are there redundant tasks or workloads running in quiet periods that have not been the focus? So maybe database reorgs can be rationalized or backups taken on a more intelligent basis. And then there may be other optimizations that you're looking at, such as making best use of your zips, ensuring adequate capacity is provisioned for that work, and minimizing any zip eligible works that might be running on the general processors. So what we want to help you with is identify who are these top consumers, who are the potential areas that are ripe for optimization. So as a starting point, you really want to know how are we doing with regards to our MSU allocation. So what we're looking at here on the left is really 2 enterprise containers that you have there in this kind of sort of artificial environment. Or one container you've used actually exceeded or reached the MSU baseline for the year since the contract started. We can show you how many, what's your average MSU consumption on that daily basis. The second container below has not reached that full baseline yet. It's 62% utilization. So you can see as you go across each month, how much more of your allocation has been consumed and how are you tracking against that. So from that point, you might want to drop down a little bit further and take a look in more detail. Monthly is useful. You get that from your SCRT reports, but it's probably more interesting to also get into a more detailed view, such as looking at the consumption on a weekly basis and see if there is a change in trend and performance that you may need to take a look at, because maybe some workloads change, maybe something has been brought online that's driving more workload on the mainframe that needs to be addressed. Maybe there's a problem that needs to be looked at. And as Dan and Butch were showing earlier, you can start to drill down quite easily to sort of start to look at the problems. So if we look at a particular week or month that's interesting, we can then start to look at, well, what MSUs, what LPARs were contributing the most to that consumption on that day, and see which LPAR is from there. And then from that point, go in and look at the workloads that are consuming there. One thing, you can then start to filter out the noise and focus in on the actual workloads that might be needed to be looked at or part of your optimization. And then the final thing that I really want to make sure you understand is that the forecasting is critical to understand how you're tracking against your expectations. Maybe it's your MSU baseline for the year. Maybe there's something else that you want to sort of just make sure that you understand how things are performing, because you're not just going to turn off machines at the last minute because your workload is you've consumed more MSUs than you expected across the year. So this example here is showing you your entitlement baseline, and the purple line is actually a forecast to say this is the trend if you're on this current direction where you will meet your entitlement baseline. And you can see it's kind of just crossing a little bit before the end of the year. So there's a little area just above the line towards the end of the year. That may be a good thing. It may be because you've brought more workload onto the system. There may be more business being generated, and the fact is that that's the trend that you're working towards. If it's not, and you're actually trying to keep things as low as possible, well, you've got enough time to forecast and from this forecast to say, okay, well, what do we need to rationalize to bring that forecast back in line to where we want to be? But the key thing is that it's given you the visibility to make that informed decision that where your forecast is taking you, you can make the rational business decision around that to tie that back. So if there is something with that visibility, which is often tricky with a rolling 4-hour average, you know, being able to support the business that may drive some more workloads, can you estimate the cost? Well, it's difficult. If it's going to push up your peak period, then that could actually be tricky, and you don't want to at a busy period, perhaps in retail or some other high volume transaction area, be able to be capping the workload so that the performance is poor. So having this visibility can help you sort of see where the workload growth is, understand the costs involved, and then tie that back to your overall capacity planning to know if you can support the business and support those changes from a technical perspective. So as I say, I'll be talking more about this on Thursday. I appreciate your time, as does Dan and Butch today, listening to us talk about capacity planning and performance analysis at a higher level. It's the kind of key summaries that I would like to just emphasize is I believe that the role of the performance analyst and the capacity planner has never been more important on the mainframe. As the mainframe becomes part of an increasingly complex hybrid cloud environment, workloads are becoming spikier because people are driving mobile initiated workloads that suddenly just drive more MIPS on the system. It's much harder to have predictable patterns of workloads. So Z being the system of record, it has to be part of your resiliency strategy and your performance analysis part. So this has been a real driving motivation for us. We need to help make the most of the data generated by the system, and you can turn that into actionable insight quicker and at a lower overhead to help you do that. So here's also some more information about the product. If you want to reach out to me, I'm happy to have a further discussion. We're obviously very welcome to take any questions now if you have any.
Okay, so I don't have any questions in the chat, but I have allowed everyone to unmute themselves. So if anybody would like to ask any questions, you can now do it both verbally and in the chat. So we'll leave that like that for a couple of minutes. Yes, feedback, always appreciated. Please, this is session 3AU. You could do it using the QR code in the Bring Your Own Agenda. There's a part where you can click to give feedback, and it's very useful both for the presenters and for us for organising next year's GSE conference, hopefully a face-to-face version.
I hope so too.
And we also have the GSE charities, of course. Don't forget to make some sort of donation there. Consider it, I've said this a few times now, but considering it buying a strip of raffle tickets. You would have done that at the gala meal with absolutely no expectation of winning anything. So just see it like that. Pop a strip's worth into the money giving. Thank you. Okay, from Brian Sanger, is it possible to link business demand with metrics to project a future issue? Does that have to be done outside the tool?
So we have the ability to tie I guess, business descriptors to certain workloads within the tool. So you can say, each group of transactions can be considered part of some kind of application or business driver, and you can report on that level of information. That you can also export the data if you wanted to import it into a business, analysis tool as well. So there's other ways of doing that. I don't know, Bruce or Dan, if you, Butch or Dan, is there any other thoughts around that one?
Well, I think the idea of bringing additional data in, we've got the ability to bring any type of file into the system. So, technically there's no reason you couldn't do it. There's nothing currently built into the product, although, we're always looking at opportunities to make improvements. And so, the ability to bring those metrics in and project future usage it would be easily done within the context of the product. It's designed to be extendable. And to be able to bring data in, that's, as I mentioned earlier, the ability to bring any structured file in. So, if you define those extra workloads as an input file, they become available and can be, included in any of the workloads.
And I would, this is Dan, I would just simply add that and also you can export to other tools as we are able to do it with Splunk and ELK. So the integration with other business metrics within those tools it's really important too, to merge the demand management piece of capacity planning into the enterprise. Hopefully that helps.
We have an okay, thanks. Come on now, don't be afraid. No questions are stupid questions.
What's that?
So I'm just trying to elicit more questions.
Yeah, if there's any more questions, funnel them through Chris, and Chris will certainly reach out to us, and we'd be glad to answer them. Post session.
Okay. Okay, well, if nobody else has got anything they want to ask at the moment, either verbally or with in writing, then I thank Chris and Dan and Butch for their time in presenting, and I also thank you for giving up your time to attend.